Hi, I'm Miss Hall, and this is Lesson 12, Modeling with Quadratic Functions, Part 1. In this lesson, we're going to have two word problems, and in each word problem, we're going to be asked to write a quadratic that models the situation that's happening. And there's two forms of a quadratic we're going to use. We're going to use vertex form if we are given a point and the vertex, and we're going to use intercept form if we're given a point and the x-intercepts. Let's start with example 1. The graph shows the parabolic path of a performer who is shot out of a cannon, where y is the height in feet and x is the horizontal distance traveled in feet. Write an equation of the parabola. The performer lands in a net 90 feet from the cannon. What is the height of the net? So there's two things here. We've got to, 1, write an equation, and 2, figure out the height of the net. We'll begin by writing an equation. So we're either going to use x-intercept form or vertex form. And looking at this graph, we have the vertex, we have the h, k value, and we have a point. We have x, y. It's best to use the points that they give you. You don't want to look at this graph and say like, oh, maybe that's a point and estimate it. No, use the information that they showed you. Don't make another point. So the formula is vertex form, y equals a times x minus h squared plus k. And we'll plug in our x, our y, our h, our k, and we will use that information to solve for a. So we have 15 equals a times x is 0 minus h is 50 squared plus k is 35. That is 15 equals 0 minus 50 is negative 50. Negative 50 squared is 2,500. A plus 35. Subtract 35 from both sides, you'll get negative 20 equals 2,500a. Divide both sides by a. It's not a. Divide both sides by 2,500, and you'll get that a is equal to negative 0.008. It makes sense that our a value is negative because this parabola opens downward. So therefore, we have all the information to write the equation. Y equals negative 0.008 times x minus 50 squared plus k, which is 35. So there is the answer to 1. 2, the performer lands in a net 90 feet from the cannon. What is the height of the net? So 90 feet from the cannon is our x value. Okay, let's switch colors. So 90 feet. What is the y value? Well, we have an equation now. And we can plug in an x value of 90 and figure out the y value. So we have y equals negative 0.008 times x is 90. And you can put that in your calculator, you can simplify it step by step, and we'll get that y equals 22.2. The y values are measured in feet. So we can say that the net is 22.2 feet above the ground. Example 2. A meteorologist creates a parabola to predict the temperature tomorrow, where x is the number of hours after midnight and y is the temperature in degrees Celsius. A, write a function f that models the temperature over time. What is the coldest temperature? Looking at this graph, we are given the x-intercepts and a point. That's why we're going to use intercept form, which again is y equals a times x minus p times x minus q. The intercepts are my p and q values. and I have given a point, and this is going to be my y and x. So I can use those 4 values to solve for a. Y is 9.6 equals a, I don't know, times x, 0 minus 4 times 0 minus 24. 9.6 equals a times negative 40 times negative 24. 9.6 equals 96a. Divide both sides by 96. A equals 0.1. Okay, so my equation, a function f, so I'll write it in function notation. So the answer to A is f of x equals 0.1. Makes sense that the a value is positive, the parabola opens up, times x minus 4 times x minus 24. So there's my function. It also wants to know what is the coldest temperature. Well, that coldest temperature is the vertex. And I find the vertex for a parabola and intercept form by adding the p and q value, 4 plus 24, and dividing by 2, which is 38 divided by 2 is 19. What am I doing wrong here? Right. Oh, that's 28 divided by 2, which is 14. That's what I was doing wrong. Okay, so that is the x value of the vertex. And it wants to know the coldest temperature, and temperature is my y value, so I plug 14 in to the function, and I get a y value of negative 10. So I've answered part A. Part B, what is the average rate of change in temperature over the interval in which the temperature is decreasing and increasing? Compare the average rate of change. Average rate of change is a fancy way of saying slope. So the temperature is decreasing. Let me finish writing this. Okay, decreasing from 0, I'll write this too, decreasing from 0, 9.6 from that point to the vertex, 14, negative 10. So I want to know the slope of that line. And the temperature is increasing from the vertex, 14, negative 10, to the x-intercept, 24, 0. So I got 2 lines that I'm going to calculate the slope of. And so I'll do the change in y over the change in x. So I subtract negative 10 minus 9.6, I get negative 19.6 over 14 minus 0 is 14. And I get negative 1.4. Remember that the y value is temperature, so the change in temperature, the change in Celsius over the time, and it's in hours. Our delivery is here.
Hi, delivery here. Great, thank you. What delivery? Yes.
So the temperature is changing is going down by 1.4 degrees Celsius every hour approximately while it's decreasing. And we can do the same thing to find the slope when it is increasing. So 0 minus negative 10 is 10 over 24 minus 14 is 10. So when it's increasing, the slope is 1. So that means the temperature is increasing 1 Celsius, approximately 1 degree Celsius every hour. And we're supposed to compare the average rates of change. So you can see that it is getting colder faster, that is a steeper line, than when it starts warming up. I'm going to use vertex form because I'm given a vertex and the point. Here is my h, k, x, y. So 20 equals a times x minus h squared plus k. 20 equals negative 25 squared is 625a plus 30. Negative 10 equals 625a. A equals negative 0.016. The equation is y equals negative 0.016 times x minus 25 squared plus 30. That's the first part. Second, the performer lands in a net 60 feet from the cannon. What is the height of the net? 60 will be my x value, and the height of the net will be my y value, so I'm looking for y. What is y when x is 60? 60 minus 25 squared plus 30. You can put that in your calculator and you'll get a y value of 10.4 feet. So the height of the net at 60 feet and where the performer lands is 10.4 feet.